Popular depictions of the Amazon often focus on a green hell, a dark, impenetrable jungle where every shadow hides a predator or a trap. The geographical reality covers 2.1 million square miles, a footprint that stretches across 9 South American nations and dominates the continent's interior. This is the planet's green lung. It houses an estimated 390 billion trees, which produce roughly 20. This combination of high rainfall, massive river systems, and extreme density creates a unique set of selective pressures, leading to some of the most specialized biological adaptations on Earth. The anaconda exemplifies these adaptations. While folklore tells of giant man-eaters, the snake functions as a vital apex predator in the river's food chain. It lacks venom, relying instead on raw muscular physics. By coiling around its target and tightening with every breath, it suffocates prey and stops the heart within minutes. Piranhas carry a similar reputation for aggression, often portrayed as swarms that can strip a large animal to the bone in seconds. In reality, they are primarily scavengers. Their triangular teeth interlock with precision to slice through bone, backed by a bite force 30 times their own body weight. This diagram reveals the electric eel's mechanics. Functioning as a biological battery, thousands of electrocytes align to trigger a 600-volt discharge. It also releases lower voltage pulses to navigate like sonar, seeing its surroundings in murky water. Even small species like the vampire bat have developed specialized tools for survival. It uses razor-sharp teeth to make a tiny incision, while an enzyme in its saliva prevents blood from clotting, a trait scientists are now using to develop new heart medications for humans. These traits are specific biological solutions to a highly competitive environment where every organism must find a unique way to survive. The physical landscape presents its own anomalies, like Shenay Tempishka, the boiling river. The water here reaches 212 degrees Fahrenheit, hot enough to kill most animals instantly. What makes this a scientific puzzle is the total lack of volcanic activity in the region to provide a heat source. Roughly 10,000 feet beneath the surface lies the Hamza River. It is a slow-moving subterranean water system flowing parallel to the Amazon in total darkness. For centuries, the Amazon was viewed as a pristine wilderness, largely untouched by human development until the modern era. Recent LiDAR scanning changed that perspective. By mapping the ground with lasers, researchers found evidence of massive ancient urban planning hidden beneath the forest. These circular foundations belong to the Kasarabe culture, proving that organized societies thrived here for over 1,000 years. They built plazas, stepped pyramids, and complex irrigation systems to manage the environment. The Amazon is a layered environment, preserving deep geological mysteries and the history of lost civilizations within its soil. Despite its immense scale, the forest faces a unique set of environmental pressures, including a surprising phenomenon known as natural acid rain. This occurs when gases from forest fires and decomposing organic matter mix with heavy tropical rain. This mild acidity leaches nutrients from the soil and can significantly slow the growth of trees that drive the ecosystem. Today, modern deforestation and severe droughts are now compounding these natural stresses. If enough of the forest is removed, the cycle of evapotranspiration begins to fail, leaving the remaining trees without the moisture they need to survive. This has global consequences. If the Amazon stops generating its own rain, it can no longer act as a climate regulator, potentially disrupting weather patterns across the entire planet. The real danger is the loss of this natural archive before we have even begun to catalog its contents. With every single year we lose more of the forest, we lose the chance to understand the secrets it still hides.